purpose of this video is to cover the basics of electronics. Voltage. Voltage is something measured in volts and it's symbolized by V. The second is current. It's measured in amps and is symbolized by an I. The last is resistance, which is measured in ohms and symbolized by this ohm symbol. A lot of times looking at these terms, seeing these symbols, they look strange and they're really intimidating, but I want to break it down to a really common metaphor that deals with water to try and explain what voltage is, what current is, and what resistance is, right? So I'm going to have a cup, right? This cup is supposed to symbolize my battery, okay? So if I have a cup and this is my battery, what is the voltage on the battery, right? So if I get a AA battery, it's typically 1.5 volts on the AA battery. So when I think of my cup, which I was going to use water, but this is a little funner, I'm going to fill my cup up to a specific height, right? So this height is 1.5 volts, right? So if I'm thinking of a battery and I'm using this example of liquid in a cup, then my voltage is the height of this liquid. A lot of times when voltage is described, they say voltage drops, right? If you see lightning, then lightning comes from the sky and comes down to the ground. So when I have a battery, this voltage wants to drop down very similar way. Just like gravity pulls apples down, electricity is tending to travel down to the ground. Voltage is this height of my water in the cup, right? So once I have a battery, I usually connect it to something, right? I connect it so that it can provide power, and that's these wires, right? So the wire is where I would be reading the current, okay? And the current is supposed to be the flow of this voltage power through the wire. And so if I go to this example with the cup and the water, what I would do is I would say I would poke a hole with this straw, boom, right into the cup, and that would be my wire, right? Theoretically, there would be liquid flowing through the straw, okay? So once I have my battery and my wire set up, I want you to understand current. So what that would mean is if I got a little tool here and I slice this straw and I look at it, either I'm going to have a small I, a little current, like a small straw, or I'm going to have a large I, would be the equivalent of like a large straw, right? So a lot of current would be a bigger flow through this chop that I make in this straw, right? So, or in this case over a wire, right? So either I have a small current, small straw, or a large current, a big straw, right? So that's how you would understand the water flowing from our cup through the wire, which is in this case a straw, right? If I got this pipe cleaner and I have my straw and I go ahead and I put it in there, well, now when it's going to flow, it's going to be obstructed, right? There's going to be resistance. So if I were to get this and chop it in terms of resistance, right, then a low resistance would be very little obstruction and high resistance would be a lot of obstruction, right? So when you're trying to wrap your head around voltage, current, and resistance, think about voltage as the amount of water in a cup, okay? Current as the flow measurement, the measurement of flow if you were to cut through your wire, and resistance alters that flow by, in this case, being a pipe cleaner that would either obstruct the flow of the electricity. So I hope that helps. The next thing we're going to do is cover how to measure voltage, current, and resistance with your handy dandy multimeter tool.